Hey everybody, this is Mr. Longo and we are about to talk about logarithm graphs and inverses. So to help you understand what a logarithm is, remember we talked about the fact that logs are inverses of exponential type equations. So if f of x is equal to 2 to the x power, the inverse of that is log base 2 of x. Now, we've already talked about the fact that 2 to the x power is an exponential growth equation, and once it's in the negatives, you're just getting smaller and smaller fractions, because 2 raised to the negative 2 is 1 over 2 squared, which is 1/4. And then as you get into positive numbers, it's just going to get bigger and bigger and bigger. So in a previous unit, we talked about inverses, the fact that they are reflection over the line, y equals x. So basically all we're doing is switching x and y's. So the inverse of f of x is equal to log base 2 of x, so we're just going to switch our x and y's. So we have 1/4, 1/2, 1, 2, 4, and 8. And our y values are now a negative 2, negative 1, 0, 1, 2, 3. So let's sketch those out. We have 1/4, negative 2. And 1/2 is negative 1. 1 is going to give us a 0. 2 is going to give us 1. 4 is going to give us 2. And 8 is going to give us 3. And if we were to sketch that graph out, it is going to look just like a reflection over that red line, y equals x, but a few things have changed. When we were talking about exponential functions, they had a horizontal asymptote that it never crossed. The blue guy would never cross the x-axis. Well, when you take the inverse of that, it's never going to cross the y-axis anymore, because all coordinates have switched. So logarithm functions don't have horizontal asymptotes. They have vertical asymptotes. So this one's at x equals 0, which represents the y-axis. And now your domain and range have also switched. So now your domain, x has to be greater than 0. And your range now, since it can go low to high, is all real numbers. And there's a right over here that's just supposed to be greater than 0, of course, because it can never touch 0. So that's what a logarithm function looks like. So it's going to start low and it's going to go high and then just kind of taper off, continuing to increase. And your domain and range are going to switch, and now you have a vertical asymptote instead of a horizontal asymptote. So that's what we have in terms of that graphically. So now let's talk about how you would actually find inverses, because it's easier to graph a logarithm function by just graphing the inverse of its exponential inverse. So inverses is the same as it was before. The first thing you need to do is switch your x and y. So x is equal to 3 to the y power plus 2. So the first thing you obviously have to do is move the 2 to the other side, so you have x minus 2 is equal to 3 to the y power. Now, this is the part where we have to remember our intro to log video, where we would have to take an inverse to get y by itself. And what you had to do was take log base 3, and that would cancel those two out. But when you're doing that, you actually have to take log base 3 of both sides. So after you do that, you end up with log base 3 of x minus 2. And that's equal to, remember, log base 3 of 3, bam, bam, cu by is equal to y. So that's how you take the inverse algebraically. And that's why we spent a video talking about inverses of logs and exponents. So the next example. Same thing, switch x and y. So x is equal to 2 e to the y plus 1. You got to get the e to the y plus 1 by itself first, so you divide both sides by 2. So you have x over 2 is equal to e to the y plus 1. We also talked about the inverse of e, which is a natural log. So in order to get an e to go away, you need to take the natural log of it. So you have to take the natural log of both sides. So that'll leave you with the natural log of x over 2. And that's equal to ln of e cancels, so you just have y plus 1. So then, of course, subtract 1 from both sides, and you have y is equal to the natural log of x over 2 minus 1. And you're good to go. Okay? So if you're trying to graph a logarithm function, a lot of times, like we said, it's easier to just graph the inverse. So the first thing you would have to do is find the inverse of this. So of course, we're just going to switch our x and y again. So we have to remember our other inverse. It would have been 4 raised to the log base 4. Those cancel each other out. So what you have to do is exponentiate both sides. And what that means is these two left and right sides are going to become the exponents. And the base of those exponents is 4, the base of the log. That's what we need. So what happened there is we just made 4 raised to the x power, and that's equal to 4 raised to the log base 4 of y plus 2. And from the inverse video, 4 raised to the log base 4, bang, bang, cancel each other out. So now you're left with 4 to the x is equal to y plus 2. Subtract 2 from both sides, and you have y is equal to 4 to the x power minus 2. Okay? Simple as that. Just make sure you are familiar with your inverses. If you're familiar with your inverses, they're very easy to work with. Last one. X is equal to 1/2 natural log of y minus 3. First thing you're going to want to do is add 3 to both sides. So we have x plus 3 is equal to 1/2 natural log of y. Now we need to get rid of the 1/2. Remember, all of our old rules of solving still apply. We're trying to get y by itself, so we have to get rid of all the other nonsense around it, unless there's something inside the parentheses with it. So to get rid of 1/2, you need to multiply both sides by 2. So you can call this 2x plus 6 or 2 quantity x plus 3. It doesn't matter. And last step, how do you get rid of a natural log? Remember, the inverse of natural log is e. So e raised to the ln will cancel, which means e to the 2x plus 6 is what you're going to have on the other side. So, final answer, y is equal to e raised to the 2x plus 6. Okay? And that's everything. So that's a video on graphing logs by using inverses of the exponential equation and how you find inverses by hand. That's it. This is Longo and I'm out. See you, bye.